Welcome back, and this is the video example, sorry, of the 11.2 notes, binomial distributions. This is example 10 that I just shut down. Okay, as with example 9, I have filled in the important information. Notice this time I reversed it. I have the number of trials up top here. The number of trials is 10. The probability of a healthy plant is 60%, so there's our 0.6. So example 10, I guess I should have typed that whole thing in here. If a seed is planted, it has a 60% chance of growing into a healthy plant. You plant 10 plants and record the number of healthy plants that grow. We want the probability distribution first. There's a table, and then we have questions to answer. So I'm going to start this the same way I did example 9. Equal, let's Excel know that we want it to calculate for us. I start typing binomial. I know this is a binomial distribution because I have a 60% chance the plant is healthy, which means I have a 40% chance that it's not. So here's binom.dist. Oops, I clicked too many times. My number of successes is what I have listed in my A column. My number of trials is up here. The probability of success is in D1. And then again, true or false, cumulative. We are not worried about the true false part. We are always entering a 0. Okay, now, because I want to fix the cell with the number of trials, I don't want it to move down. And the same thing with the probability. I'm going to fix those, hit return, and I have a probability of 0 healthy plants of 0.0001. Again, I can take a look, this little green box on the corner. If I click there and drag down, it fills in all of my probabilities, and you should be able to double check. Those are the probabilities that you see on page 6 for example 10. So let's answer some of these other questions. B wants the probability of 4 healthy plants. Well, here's my 4 healthy plants. The probability of 4 healthy plants is right here. The nice thing about Excel is if I slide it in, it will round to the correct place for me. So if you are unsure of how to round, slide it on up till we have 4 places. C wants the probability that 3 plants don't grow, which is actually going to equal the probability that 7 healthy plants do grow. And so I'm going to find my 7 healthy plants right here, hit enter, and then go ahead and slide this up. So, oops, too far. Oh, so the 21499, the 9 rolls up to a 0, that 9 rolls up to a 0, and so this is 2150. I knew that. B, what's the probability that at most 7 healthy plants grow? So the probability that X is less than or equal to 7. Here we're going to sum. I want all of the X values that are less than or equal to 7. And so that is my probability from 0 to 7. And we get 0.8327. E wants the probability that at least 5 healthy plants grow. So we want X to be greater than or equal to 5. All of the values that are 5 or above. I got an equal sum again. Here is my 5. I want 5, 6, 7, 8, 9, or 10 healthy plants. It is 0.8338. And F is asking for the probability that we've got between 2 and 8. If it doesn't say inclusive, it is up to you as to whether or not you want to include those bounds. Here it says between 2 and 8. It doesn't say to include 2 and 8. So I'm going to go 2 strictly less than x, strictly less than 8. Actually, let me rephrase what I just said. It will say inclusive if it wants you to include those endpoints. So sum between 2 and 8, not 2. So 3, 4, 5, 6, and 7. Close that off and we get 0.8204.